last video we ended up with the explanation why we have to make this proof to come from this step to this step. And the next step is we'll be looking at this expression here. And this is an expectation value of a function. And we looking a little bit back to the expression what is a expected value, and we have an expected value from a sample, and we can do, of course, an expected value from everything, so from a function. So we can use this expression, and instead of this example, we can put there in a function, and it looks in this way. In general, e from a function from xe is the sum of the function from xe times the probability of the xe. So nothing exciting happens here. It's just the original expression included this function. So in our example we have this function here. So we can go on and write the sum of xi minus mu squared times the probability, and here again we have a uniformly distributed population, so we can rewrite this as 1 over n, and 1 over n is a constant. We can put it in front of the sum sign, so again we can write 1 over n sum x minus mu squared, and this expression here should be come to our mind. This is the original expression of variation of xe. This is the standard definition of variation of a sample. So this expression, not the sum sign not included, means the variation of xe. So we can rewrite this expression here as the sum. Okay, like the whole term here. No, not the whole term. This term follows later. So the sum, this sum sign here, the sum of the variation of xe. So if we sum up the variations, that means, as we said before, as I said before, if you sum up a thing from here's 1 to n, is always 1 to n, then you have n times this variation of xe, because this is a constant. The variation of xe doesn't change, so this is a constant. You sum up a constant, and this is n times the constant. So again, this is n times the variation, or variance. So variance of xi. And altogether we have, let's change the colors. We have now here the complete expression is 1 over n minus 1 times n times the variance of xi, and this expression here, n times the expected value of the average minus mu squared, and parenthesis, or parenthesis. So now we look at this term and we see it is almost like this expression, except one difference. This is xi, it means the single examples, and this is the average. So we have to consider different things, and again it gets a little bit hairy, because this is sounds almost equal, but almost equal. So what we have here is just the variance, or that is, or the sum up variance of xi, and here we have n times the variance of the average of the sample. So and to rewrite it, this expression is again the same steps as here. Instead of xi, we have the average of the sample. So this expression means different color. This expression means not this the n, no, just that. This is the variance of the average. And yeah, again, just with the same steps we made here. Instead of xi, we said x the average, and continue, and we get the variance of the average. But we want it in a different expression, like something like that. And so we have to move forward, and again we can rewrite this average as the variance of the sum of xi divided by n. And this comes again, we have seen it before, from the definition of the average, is the sum of xi's divided by n. Just rewrite the things. So now we can again rewrite it to make it definitely clear. This means 1 over n sum of xi. So, and now we have this expression, and we now shall calculate this variance. But here is in multiplication, so we have to reconsider the things, and another sidestep proof is necessary to move forward. And we have to answer the question. Now we have to calculate the variance of a function of xi, not only xi, not only xi, but sum of xi and another term in the parentheses, and where we have to go to linear transformation, because another color, this yellow again, the variance of a linear transformation means something like that: a plus b times xy. If you have to calculate that, it means, for instance, you have euros, and now you change your money in dollars. Is the variance of dollars equal to the variance of euros or not? Or is there something to consider? And there is something to consider, and we do it step by step. And what we need is two more things: the mu from the new from the transformation transforms as a times b mu x, and the single expression y transforms as a plus xi. This is the linear transformation thing, and we see you in the next video.